Uh, Good afternoon, colleagues, and good afternoon, everyone. It's 2 o'clock exactly on my side, and I would like to welcome everybody to our session on the promise and peril of using AI in the public sector. And with me, I have Professor Fourie, the chair of the Policy Innovation and Lab at the Stellenbosch University. If you can help me welcome him to present in our webinar today. And he brings with him a wealth of knowledge and experience in the technology-driven policymaking space. He has advised global institutions like African Union, United Nations, and EU. Please let's have an engaging session. And with no further ado, I'm going to hand over to Professor Fourie to take us through his presentation for today.
Thank you, Nobuntu, and good afternoon, everybody. I have a bit of internet connection problems this afternoon, so just to check, Nobuntu, can you hear me clearly? Can you see me? Is everything fine?
Yes, on my side, I can hear you and we can see you.
Wonderful. Okay, yeah, it's a huge privilege for me to be joining you this afternoon. I'm seeing 56 people have joined 2 o'clock on a Friday afternoon. That's really impressive, and thank you very much. I will be sharing my presentation or my screen shortly. I'll be dimming the lights. No, I'm joking. I'll be killing the camera at that point. This is just to show you that I'm not an AI-generated persona speaking to you today. And thank you once again for the opportunity to speak. Yes, as Nobuntu said, I'm going to speak to you about the promise and peril of using AI in government, in the public sector. And I would like to invite you to pose your questions, your comments, your thoughts throughout the session. As Nobuntu said, we really want this to be an engaging session and want you to walk away with having learned something. And one learns best, that is something I've found by engaging, by asking questions, by applying your mind. So really, please use the chat function. I'm going to check it every now and then to see whether there's a question or a comment. Okay, let's jump in. So the structure of my presentation today is the following. I'm going to start with a short little overview of what we do at the Policy Innovation Lab here at Stellenbosch University. Then a little disclaimer, you see the smiley face, what this talk is not about. As any academic would know, and I think as many of you also know, it's always good to manage expectations, certainly when it comes to an expansive topic such as artificial intelligence and its use in government. Then a little refresher, and I think for some of us it might be more than just a refresher, but a reminder of what AI actually is. And the related question, how do these AI machines learn? We look at a couple of cases, emerging uses of artificial intelligence in governments around the world, a little nerdy piece of application on AI and qualitative data, that is words. So not only analyzing numbers, but also words, how AI can be useful in that respect. Then the second last section, looking at opportunities and risks of AI in government, and maybe some imperatives. What should you consider in your organization, in your unit within government, if you want to make the most of AI? Before I do so, however, I would want to invite you to use the chat function just to give me a sense of where in government you're from. And those of you not from government, yeah, are you in academia, in business? So type in the chat box the department or the unit or the organization you're involved with. I'm going to give you a couple of seconds for that. That will help me also to understand who's in the room today. Yes, GTAC, wonderful. More GTAC. I'm seeing some AI note takers, which is always good, keeps us honest. Ilifa Labantwana, an NPO, GTAC, Chief Procurement Officer's Office, JB Marks Municipality, Treasury, GTAC, our friends at the Environment, Department of Justice, Constitutional Development, Job Fund. I'm seeing a nice mix of people, Stellenbosch Municipality just around the corner, advisory sector, local government also represented here once again, Treasury, National Government. EFM. So I'm seeing, and please continue to type where you hail from. I'm seeing a wonderful mix of local government, of national government, of provincial government, various sectors represented, constitutional development, law enforcement, treasury, of course, GTAC. Excellent. Yeah, okay, great. A good sense who's in the room. Okay, let's jump in. Just the Policy Innovation Lab. So that's where what I'm involved with, that I'm privileged also to lead. We're an entity within the School for Data Science and Computational Thinking. You can also see that in the footer of my slideshow at Stellenbosch University. We do two interrelated things. We look at responsible artificial intelligence for transformative policymaking. That means we cover two overlapping topics. One, the policies, the processes, the governance structures relevant or necessary to use responsible artificial intelligence responsibly in government. We are not one of those technological optimist groupings where we think you just dump technology on people and institutions and everything will be fine. No, making use of technology effectively is a deeply human process. And we're acutely aware of that. And then we also do look at the tools, the technologies, the infrastructure. And we try to work also at that intersection quite often. So both prototyping tools to transform policymaking and then also reflecting on the responsible use as it relates to capacity building, the policies, the process, the governance structures that need to be in place. Yeah, so that is what we do at the Policy Innovation Lab. Now let me start as any good academic would with a disclaimer and a couple of notes on what this talk is not about. Artificial intelligence is such an expansive topic, it is impossible to cover all the fields of application of AI in one talk, in 1 week, possibly even in one series of lectures that covers a month. AI is all around us. It is part and parcel of many of the things you do. Even a simple Google search is enriched with AI. Using all of us have AI assistants on WhatsApp. I mean, AI is all over the place, and in many places it's being used where you don't, without you even realizing. The point is, this talk isn't about all the fields of application of AI. That's certainly just impossible. It's also not about all the types or all the components of AI. If we start talking about AI, we need to talk about data, for example. How do you source your data? How do you clean your data sets? How do you train your machines? How do you develop algorithms? What makes for a good or a bad algorithm? And then how do you deploy all of these things in systems? We're not covering all of this. It's simply impossible. But we'll be looking at some snapshots, some components, some elements of AIs. Again, it's also impossible to look at all the risks and all the opportunities. I mean, that's quite obvious because AI, the field of application of AI is so wide, because there are so many components and elements of components within AI systems. It really is impossible to look at all the risks and opportunities. But again, the intention is a snapshot, a couple of ideas that could be of use in your work. As I've said, it's a snapshot emanating from our work, and it's a challenge to perhaps consider more options. Apologies. For using AI and maybe to become more reflective, more responsible users of AI systems. Now, as I've said, we talk about AI often, it's all over the place, but very often we don't ask ourselves, what is AI? We assume we know, often we don't. So in this part of the, let's say, relatively theoretical part of the presentation, I'm going to look at what does the word AI mean, and relatedly, how machines learn. Before that, I'm going to ask you to type something in the chat again. And on a scale from 0 to 10, what is in your view, your technical knowledge of AI systems? So 10 would be, I know everything there is to know about AI systems. I mean, maybe there's nobody that can be able to choose a 10, and 0 is, yeah, I'm just a beginner. Oh, 0 is nothing, and then 0 to 5 is I'm a beginner. I'm still figuring these things out. We have a 6, sort of on your way, a 2, a 5, a 3. I love these numbers less than 5. Because to be honest, most of us, I mean, we're really not that conversant in AI yet. And it's a funny thing because it's all around. We use it in our work, but we don't know that much. Even myself, I must say, so I have a social sciences background. And then I got involved in the application of AI in various respects. So at my previous institution, University of Pretoria, I started the natural language processing team. I worked for a global tech company for a while. I even co-founded a legal analysis AI startup, and now I lead the Policy Innovation Lab, where we do many things related to AI. And even in this position, there is always something new to learn, both because the field is so broad and because the developments are so rapid. Many of you might be subscribed to AI newsletters, but those of you who are will realize that every day, basically, or at least every week, there's a new development. So let's look at what AI actually is. Something we don't realize is that AI has a biological inspiration, like many technologies. Those of you who had biology at school, and this is maybe many decades ago, might recognize this cell. It's a neuron. Those are the cells that help us think, that relay messages to and from our brain. And that's also the earliest inspiration of AI systems, is biological. Now, this biological inspiration developed, I mean, you can look at it many different ways, but one way of looking at it is saying that it developed along 5 phases. Now, to get you into understanding what this AI thing is, I'm going to map out what these 5 phases were all about. Now, the first phase was centered on something called the perceptron, and this is many decades ago. It wasn't just yesterday. Now, this looks like a formula, but if you reflect on this a little bit, you see the green, there are inputs, and then the dark blue, the Y, something happens, there's some calculation, and then there's an output. And that's analogous to how our neurons work. You get perceptions through your senses, you have input, there is some calculation happening, and then depending on whether or not a certain threshold has been breached, there's an output. And the output often is that the signal is handed on to the next neuron. Or handed on to parts of your body or your brain that tells you what to do next. So it mimics this perceptron, the first phase. Extremely simple. It wasn't AI in any real sense. It couldn't do anything basically apart from mimicking the simple neuron in its structure and how it processes signals. Important also this threshold mechanism. So deciding if the perceptron receives a signal, whether it should hand the signal on and do something with it. And you'll see later why this threshold mechanism, it's really technical, is important. Now, those of you who already feel a bit lost, hang on. This is the most technical part of the talk today. After this first part, we'll be looking at applications, a bunch of other things, but see whether you can stay with me. Now, those of you who had biology, there's a dendrite in the neuron. In the perceptron, that was an input node. There's a cell body. In the perceptron, that's the weight and summation function. And then axon and synapse, that sort of gives it further, that's the activation function. Just to make the point that the first phase of the perceptron was modeled on how our body works. Now, one cell isn't good enough. Even a line of cells or a succession of cells isn't good enough to do intelligent things. And then that's why the scientists realized, well, we need to make this thing more intelligent and also more analogous to how our cells work. And during the second phase, they introduced something called a hidden layer. Now, I mean, there's nothing secretive about it. Essentially, that is a layer that does initial sort of combination of calculations before it comes to the activation function, making it a little bit more complex. The focus then also shifted to building networks rather than just only looking at single linear succession of perceptrons. Then they said, well, I mean, what makes our brain and our neural system so wonderful is we learn from experience. Now, it looks sort of dangerous if you look at this thing with all the arrows. Basically, the point is it's not one way. It didn't become one-way traffic anymore. But there were feedback loops and all kinds of fancy terms. So you want to impress your nerdy friends, start using words like backpropagation, backward past, weight updates, all those things. That's the point is it started learning from experience. People often say, well, what is this? How to explain this to me in simple terms? Think of a medical analogy. You go to the doctor. You present with certain symptoms. The doctor looks at the symptoms and say, based on these symptoms, I prescribe the following medication. You go home, it doesn't work. You go back, and the doctor says, well, okay, I need to update what I did. So you didn't breach the threshold. I mean, the threshold would have been breached if the medicine helped. You wouldn't have gone back. Now the medicine didn't help, so you have to go back to the doctor. So that arrow is going back, and the doctor prescribes new medicine. And the threshold in this case, getting better, is breached, and then you get better. You don't go back to the doctor. So basically, the doctor learned from experience. And that's sort of the logic in learning from experience in AI systems. Then they said, well, even this isn't enough. So the perceptron on its own wasn't enough. Making this networks, no, not enough. Putting this, setting up a system that learns from experience, not enough. They said our brains are specialized, actually. We have certain neural networks specializing in certain things. If you see an object, for example, certain neural networks help you recognize the color, others help you see the texture, others help you see the form. And that's how we recognize objects. And that's what started happening with the AI system, mimicking the regions in the brain. And then the computing power became just much, much better, the hardware running all of this. And the networks could just be much, much more complex, computationally more expensive, if I can use those words. Anyway, so that's in essence the phases through which artificial intelligence develop. I haven't defined artificial intelligence yet. So what is artificial intelligence? Simply technology that enables computers and machines to simulate human intelligence and our problem-solving capabilities. It looks a little bit like human intelligence. That's the point. Are the machines intelligent? That's a different question. If you use ChatGPT, for example, it simulates human reasoning without actually understanding what it's telling you. So that's why this word simulation is quite important. You can also distinguish between weak or narrow AI and a broader definition. So let's first look at weak, narrow, or narrow AI. That's AI trained and focused to perform specific tasks. Up until relatively recently, that was what AI was doing. But now we have general purpose AI models, ChatGPT, or the large language models. They can do many things. But it's initially weak or narrow AI. And then you have a strong AI definition. We really aren't there yet. But this is perhaps, we don't even know whether it's possible, going towards artificial general intelligence, that's self-aware and conscious machines with intelligence equal to human brains, and even artificial superintelligence. Machines with intelligence that surpasses the intelligence and ability of the human brain. Explicitly, many companies are pursuing AGI. We might not even know when we have achieved it, but the machines are really, really advancing at an extremely rapid pace. At this point still, it might change soon. Strong AI in both of those definitions, only a theoretical possibility. Now, I love this graphic because it helps us distinguish between these different topics and words and concepts we use. So sometimes we conflate data science and artificial intelligence, but they're actually two different things. Data analytics, interestingly enough, you needn't see that as a part of AI, but rather something that's at home in the field of data science. Big data overlaps because you need that big data for both data science, data analytics, and AI. And then within AI isn't only machine learning, but that's an important component. And within machine learning, you have the deep learning component. I'm going to pause for a second. If there are any questions on just AI, the development of AI systems, how these different components link to one another, you can also just type questions or comments. Yes, Tabiso, please go for it.
Hi, thank you. How does RPA link with AI?
Sorry, what's RPA? Yeah.
So robotic process automation.
So I mean, I can't give a direct answer, but the robotics is it's the infrastructure very often, but there's strong integration. If you look at what Google's doing these days, for example, very recently within I think the past week, they announced the integration between the robotic systems and the AI systems. I'm not a robotics expert, but from my perspective, maybe the AI is a bit more the brain of the physical infrastructure, but I could be wrong. So yeah. Thanks for the question, though. Brian, go for it.
Yes, thank you so much. I mean, this is very insightful. We had that the one page where there was the AGI and the ACI, the super intelligent. In your opinion, and I'm sitting here and I'm thinking to myself, I don't see us having the safeguards to say people can't, how human beings are like, that there are going to be organizations and individuals that are probably going to be seeking that ASI, the super intelligent. What are you of the view? I'm sitting here now and I'm of the view that we're going to reach that, because that's what human endeavor is, to try and go beyond the boundaries, right? Beyond the general intelligence. What's your view on that as well? Do you see us achieving that at one stage?
Well, I mean, if we listen to what the tech companies are saying, they're saying, yes, we will. I think I would be surprised if we don't. Also with this, the quantum chips and stuff that's been released now. Maybe something else you've indirectly also touched on, and that's a regulation of this. So how do policymaking stay up to date and ensure that these things are regulated well? It's an extremely difficult thing. Actually, I have an opinion piece in Daily Maverick. It will be published sometime next week, where I highlight the difficulty of policymaking in this context. Because there's the issue of proliferation, so these systems are in the hands of basically anybody, and it's extremely difficult to track malicious uses of this. So we're in for a thing, and certainly policymakers will find it really, really difficult, I think, globally, not only in South Africa, to regulate this. But my view is, I have to guess, I think we will, AGI and ASI will probably be reached. Now let's look at strongly related topics, and that's how machines learn. Three concepts are often bandied about, and I think it's important that you know something about it. One is supervised learning, the other is unsupervised learning, and the third is reinforcement learning. Really forms the basis of many, but not all AI systems. And I like this medical analogy again. So supervised learning is really the easiest to explain. That is where you have pieces of data that are labeled. Now, this is X-rays. Let's say you are training an AI to recognize fractures. So you give it thousands, ideally millions of X-rays of fractures that were already labeled by human beings, saying this is a leg fracture. I mean, I'm not a medical person, but sort of expert humans gave labels, correct labels to these X-rays. And then at some point, the machine is faced with unseen data, and it can correctly predict what it's seeing. I mean, a much simpler explanation. Think of children. Many of you might have children. I have my own children. I'm fascinated by how they learn. Think of something simple like a chair. Chairs come in so many shapes and sizes. The sizes, colors differ, the size differ, how long the legs are. Some chairs have back sides. I don't even know what you say, but a large variety of chairs. Now your child sees thousands of chairs, and you tell them this is a chair, this is a chair, this is a chair. At some point, they see something that they've never seen before, and they have the intelligence, the knowledge to predict correctly that this is a chair. We actually don't know how they made those connections, and that's a little bit similar to supervised learning. Then we get unsupervised learning, where the previous medical example was you presenting a machine with labeled X-rays. This is slightly different. Imagine presenting a machine with doctors' handwritten notes. I actually asked the AI to generate this little pictures you see as we expect with doctors. You really can't read the notes. That's not the point here, but the point is unstructured data. And through statistical means, and mathematical means, the machine identifies structures and patterns in the data. And then there's a third, and ethically, I think the most challenging, also in terms of policy making, amongst the most difficult to regulate, and that is reinforcement learning, where an agent interacts with its environment and it receives rewards for good actions and learns them through this feedback to improve its performance. Imagine you have a prosthetic hand, you're teaching this thing to pick up a cup. Of course, the reward is when it realizes it has a grip, The opposite of the reward is when it drops the cup and it realizes this configuration of movements was incorrect, and at some point the thing learns how to pick up a cup. Now this can be applied to many, many, many different contexts. This is the three main paradigms in terms of which machines AI learn. Okay, so this is just a crash course in AI. A little bit the development of AI, and then specifically also the paradigms or the ways in which the AI systems learn. Most AI systems currently that we're using use a combination of supervised, unsupervised learning and reinforcement learning. Just gives you the idea how they learn. Now we move to slightly more practical matters. First, we'll be looking at cases, emergent uses of AI in government. And then we'll be looking at a specific area, and that's the use of large language models and the benefits and the opportunities using them in government. Again, let's pause for a second. If you have any questions or comments on the learning paradigms, reinforcement learning, supervised learning, unsupervised learning, any thoughts or comments, you're welcome to unmute yourself and you can also just make a comment. So open invitation also throughout my speech. As I speak, you can raise your hand or you can type a comment and we take it from there. Now, let's look at AI in government. Not that much data available on AI in the South African government and African governments, a little bit more in some other governments, but I think some of the lessons are transferable also to our setting. I start, however, with the expectation, with asking questions on how or to what extent South Africans are using AI. Now, I'm going to show you the graphs very soon, but just to prepare you, so what we're going to see is comparison between how American, European, other users use AI and how often they use it versus how users in selected so-called emerging economies use AI. These emerging economies are South Africa, Mexico, Brazil, UAE. I think maybe I've forgotten one. Anyway, and this is really surprising. So emerging, yeah, Brazil, Chile, Mexico, Nigeria, South Africa, UAE. The question is, how many of the respondents have used AI in the past 12 months? By far the largest number in these emerging countries, including South Africa. More than in the US, Europe, Asia Pacific. Any surprises? Maybe raise your hand or make a comment if you think, I mean, I was really surprised when I saw this. Anybody else surprised, or was that something you expected? You can use that.
I think Nigeria is using a lot of AI.
Say, who's using a lot of AI?
Nigeria.
And you think that's skewing the data a little bit? I mean, it could be. I mean, if you look at the raw numbers, of course, Nigeria, a country with a large number of people. Victor, I see your hand is raised. A comment, or you're just agreeing, you saying, you did expect this?
Yeah, I'm just agreeing. I didn't expect this, honestly.
Yeah, I must say, I am surprised by let's forget about the high levels of usage in the emerging countries in the sample. I am surprised by the low levels of usage, certainly in a country like the US, for example. Now, Sibonego, I see your hand is up. Go for it.
Thanks, Prof.
Yes.
I wanted to find out, was it defined what AI is in this context? Was the tool specific that we said these are the tools that use AI? Was there some description to the survey itself?
Yeah, I need to go and look at it again, but I think it was a generative AI survey. Yeah, so the typically your large language model type things, but I'll check again and I'll get back to you on that. Okay, I mean, there's a second one. How AI was used? Most from the emerging market said they use it for entertainment and to assist with work and to assist with personal communications or projects and schoolwork. I mean, tongue in cheek, I must say I'm surprised that it's only 77% of the students who said they use it at school or learning. I think the numbers are really, really high at universities. Gives you a sense of what people also are using AI for. And again, I mean, this reflects what we saw in the previous graph. Okay, so this is just for context, that there are high levels of AI usage, at least among the respondents of the study. Now, if we zoom into the government sector, the public sector, what are governments using AI for? Now, some of the most recent data actually focuses on European governments. About a third said they're using AI now for anti-fraud audits, some knowledge management. In my view, that makes a lot of sense because governments use words, and the newest AIs do well with words. Chatbots, virtual assistants for citizens, and then fewer for employees. And then you also see in the next slide, emerging use is also in procurement processes and actually automating some of the procurement processes. If we look at anti-fraud audits, there's much of the AI use. There's also quantitative uses. So picking up anomalies in the data and then acting upon it. Of course, the banks are also using that extensively. Now, there's also what they call a horizon map of AI use in government. So to some extent, based on the existing data, the progression of AI use. So I'm just going to... So Horizon 1, that's use cases that are currently being deployed, and that's what we've seen here. Of course, the fraud detection, drafting documents, creating schedules, summarizing meetings. I mean, this happens sort of automatically translating stuff. They add HR chatbots here. It's a little bit the older-fashioned type of chatbot where just making sense of all your policies in organization, even help desk chatbots. So as we go up or along these horizons, Horizon 1, 2, and 3, the logic also is that the more sophisticated AI uses, but also the more experimental AI uses, is where the AI systems become more autonomous, a bit of a strong word, but less reliant on human oversight for certain tasks. Anyway, so that's Horizon 1. Oh, sorry, apologies. My AI... I didn't put my phone on silent, apparently. So the second horizon you'll see is that's cases that are currently being piloted, and that is citizen chatbots, for example, drafting RFIs, RFPs, software code generation, testing, Q&A, and then also analyzing citizen sentiments. It's still emerging. It's not the most accurate use of AIs, I would say. But something that's useful, and then also summarizing bits applications. Now, the summarization in this Horizon 2 more is at stake because it's summarizing more important, more granular documents where you have less scope for mistakes without making a big mistake. And then Horizon 3, those are cases that are being explored for future investments. And as I've said, this is where the AI systems get a little bit more autonomy. So simulating operational policy strategies, combining AI and generative AI with other automation tools to proactively, that's the key point here, deliver so-called no-touch services. So running a task from beginning to end and concluding it. Even building 360-degree views of citizens for case management purposes, having a sense of which clinics the citizen visited, interaction with, let's say, Home Affairs, interaction with some other parts of government, even maybe incorporating their engagement with the local government and getting a 360 view of the citizen, also to help the citizen better, but also pick up cases where citizens need to be followed up with a little bit more stringently. So these are the three horizons currently. Now I'm going to pause once again for your views on which of these use cases, usages do you think could be transferable also to the South African setting? While you think about that, I see Stevens is asking how much is AI being used in the health sector, so to predict prevalence of brain tumors, cancer. So, I mean, the positive thing of the health sector is you have a lot of data. So you can really train the machines quite well. Another positive, if I might put it that way, is that health professionals in the public sector are typically under a lot of pressure. So they are in need of some innovations. And there are many experiments, articles on usages of AI in the health sector, like a lot. But I mean, we're talking about life and death here. So the risks are also particularly high. So that's why it is an interesting but a difficult sector to deploy AI in, because you don't want to make mistakes that cost. You really don't want to make mistakes that cost people's lives. And yes, we have a hand. Please go for it.
Yeah, thanks, Prof. You know, when I just one time saw a program where in Japan, I think it's in the health sector, where they actually took a number of scientists, and I think there were 20, and they showed how long it will take them to actually predict or can actually see the possibility of cancer in a patient. But it took AI 20 minutes to actually find the same predictability. So it was quite interesting, and how it actually could go through all these journals in less than 2 seconds. When if you were a scientist, you'll probably take a month to go through the journals.
Yeah, and even now there are very powerful tools that you can use for that exactly. I mean, this brings me to a point that I should mention, even though I'm not covering it in detail in this talk. We tend to focus on all the fancy stuff AI can do, which is really important. What we forget is that for the AI to be effective, it's about collecting data. If you don't have the data, you won't be able to do anything. Cleaning your data. So if the data isn't in a usable format, you can't do it. And of course, protecting your data. You need to, I mean, if you have a lot of data, especially sensitive data on citizens, you need not only to collect and clean it, but you need to be able to protect it. And there are some of the AI experts, also South African AI experts, who say we should spend much more time thinking about how we collect and make use of data, and also the large volume of public data that's just not readily available. Focus on data first before we start talking about using the data. And that certainly goes for in the health sector, also responding to the other question again. If we don't have reliable data on health data, of course, you can't really use the AI that well. This is some of the cases now, yeah, as I've said. Now, a particular type of application is AI and qualitative data. That's something I'm quite interested in, and I think something that can be of huge benefit also to governments. And I'll explain a little bit more what I mean. Now, if we talk about the type of AI systems that analyze qualitative data, we're not talking about AI as a whole, but we're talking about specific sort of flavor of AI, and that's natural language processing. Now, those of you might start, if you haven't heard this concept before, you'll start recognizing it. NLP, or natural language processing, is something that's often used, and that's what the large language models, your ChatGPTs and those are to a large extent based on. Now, NLP is a subfield of AI, and it focuses on the interaction between the machines and human languages, sort of tongue-in-cheek. Of course, you also get machine languages, Python, and all the different things. So this is human languages. And these NLP systems are designed to process and analyze large amounts of natural language data, such as academic articles, for example. Analyzing these articles, looking for patterns, summarizing them. That's NLP. There's this picture that I also always found helpful. I showed you the earlier one. This is just understanding NLP. So we have AI in the middle. Subfield is machine learning. In a smaller field, deep learning. And then NLP partly overlaps with both. But it brings together linguistics, learning about languages, and computer science. So that's the type of tools that could also be of particular use in government context. Why? Because they analyze qualitative data. What do I mean with qualitative data? I mean, it basically is words, paragraphs, documents. A slightly more academic definition is non-numerical information that captures the qualities and characteristics of the subject, often expressed in the form of words, sentences, and paragraphs. Governments across the world need to deal with large amounts of expert data, of reports, of policies. And quite honestly, I think in many cases, our human minds are just, we can't process all of that information. It's just too restricted for that. And that's where the NLP system are quite useful. Now, what types of publicly available qualitative data do you have in government? Of many things I've mentioned, but also speeches, minutes of meetings, social media, all those things. Previously, even a couple of years ago, it would have been unthinkable, impossible to make sense of those sorts of data by the press of the button. It's not impossible anymore. Now, there are various ways in which the AI systems can actually help us make sense of qualitative data, this non-numerical data. I'm going to run through a couple of options, and then I'll pause again for discussion. One is data processing and analysis. So basically, making it possible for the AI, or providing reports, policy documents, news articles, and getting the AI to extract meaningful information from that. Another one, I'm going to show you a picture of that, is topic modeling. So giving the AI a large volume of documents and ask it to identify themes and topics. That can help you to detect emerging issues in legislative documents, identify trends in public discourse, many other uses. But imagine this. You give the AI system a large number of documents, and then it's a bit like a mind map. It identifies the main topics and the connections between the main topics and other topics. So you'll see all the green stuff and subtopics relate to religion, for example, orange to literature, performing arts. So you can see this was a specific type of text, but the AI systems can do this for any text. So doing essentially a topic analysis. Another way, and I don't have a visualization for that, but that you can visualize this, is basically a word cloud. You've seen word clouds, and at the back end of that now these days is AI systems. AI systems can also make sense of qualitative non-numerical data in other ways. I talked about sentiment analysis. I mean, I'm honestly not the biggest fan of sentiment analysis yet, for many reasons. I don't think it's that accurate always. Sentiment analysis also for local languages or local dialects or local ways of speaking. If it's not in the global north with a lot of training data, sometimes sentiment analysis isn't that accurate, but it is an exciting option, exciting possibility to gauge public opinion on government policies, even to do stuff like predicting civil unrest or on understanding citizen sentiments. This was an article a team, I think, at University of Pretoria wrote, that was actually looking at the sentiment linked, I think it was on X or Twitter those days, to the president, the presidency, linked to COVID and the COVID-19 response. Now, let me show you. So you'll see Cyril Ramaphosa in all three, and then they calculate the number of times it was associated with a positive sentiment, number of times it was associated with a negative sentiment, and how often it was associated with just a neutral sentiment. The same goes for all the other topics. I mean, this is basically what sentiment analysis looks like. In practice, you can do it for anything. This was an interesting article on what happened during COVID. Then there's another tool that the NLP provides, and that's named entity recognition. So it is clever enough to identify entities and sometimes even people within pieces of text, and that can help you track interesting developments. So I mean, the example I'm going to show you now is a NLP tool was presented with information on household appliances, simple thing. And that's the type of analysis then it gives you. All the yellow stuff, it could figure out was related. LG, GE, oven, microwave, refrigerator, that's the same type of entity. Then if you move to the brownish things on the right, you know, the charger, a battery, a saw, Bosch, seems to be the same type of thing. Light blue to the left, your kitchen stuff, kitchen table, vanity, sink, bathroom. Yeah, it's actually not just kitchen, but everything where there's some sort of plumbing involved. And so not only identifying the entities, but also clustering them together is something you will typically see. Just a little nerdy thing, if you allow me. You'll see here to the bottom, you'll have kit valve in green, garden hose, sprinkler. And then you have the dark blue dots, deck, concrete, and grass. And you'll see those clusters are a little bit less defined. So the yellow cluster is quite well defined. The brown cluster is well defined. The light blue one is well defined. But the dark blue and the green cluster is sort of mixed in. Of course, because you will find a garden, for example, and grass sometimes coexist, but sometimes your grass concrete deck is actually what's outside, external to the house. So that's one logic of connecting them. But of course, grass and garden, grass and hose also sometimes coexist in a text. Just an interesting thing that the name entity recognition does. Before moving to opportunities and risks, let's pause again for just a general discussion, for some comments. I've shared some use cases also of natural language processing type tools, also some other use cases. Any thoughts and comments? While you think, I see Monia saying, are there existing policies, rules in South Africa to govern, guide, and regulate the use of AI? How do these compare to international approaches? Are we prepared? I don't think any country is prepared, Monia, to be honest. I really don't. There are different regulatory approaches. So the approach up to now in the US, for example, is a little bit more less regulation. And people would say lower regulation means higher innovation. I mean, it is sometimes true, but that's the US, the EU, as their AI Act, which is a risk-based approach. So it's a very well thought through piece of legislation where they classify AI systems in terms of their risk, and then the adequate responses based on the level of risk. The expectation is among many people that the European Union's AI Act might become not the default, might be used in many other jurisdictions. The GDPR, for example, the Privacy Act, on personal, basically our POPIA was really inspired in many respects by GDPR, as was many other countries' similar legislation. And the expectation is that the EU's AI Act might have a similar global impact. There's also a national AI strategy in the works. UN is working on regulating AI usage. I see Kanya. I mean, yes, the problem with the multilaterals is that they don't, AI regulation policies are enforced at the national level, not at the global level, I would say. So that's the problem with multilateral regulation. And the other really major challenge is that the tech companies, of course, work at a global scale, but regulation happens at the national level. And there's this juncture there, which I think is quite challenging and something that needs to be addressed. I don't know how, to be honest. Any other comments? Just AI, these different uses. Are there surprises? Are there other things you've heard of? Other ways in which you think they could be useful in the South African government context? The floor is yours. Brian, go for it. Thanks.
Thanks again, Prof. I think, well, I don't know about the other guys. One of the things that maybe you might touch on it later, and I think it was the biggest concern that just about ran in parallel with the whole explosion of AI onto the global stage, in terms of how it was going to take over jobs and what have you. I mean, I've had a conversation. I was having a conversation with friends of mine a couple of months ago, and one guy insisted on the fact that, because one of my strengths is Excel, Microsoft Excel. And one of the guys there, I don't know whether he was prodding me or what he was trying to get out of me, but was on about how now you can get Excel to do AI to do Excel formulas for you. But my contention is that if you don't know what to ask AI, you never really get anything out of AI. You have to understand the formulas that exist within Excel, or how to use them, that you can ask the particular question. Within the next 10 years, 15 years, I'm a 50-year-old, and my thinking is, by the time I go into retirement and AI is taking over these jobs, I'll be busy in retirement. So do you believe that there's going to be, within the next 10 years, an potential increase in AI usage and a corresponding decline in jobs, human jobs?
Yeah.
How much of a threat is it?
Yeah, I mean, the question on AI and Excel and even AI and basic writing, there's really a growing body of research on linking AI and de-skilling. But put differently, where they look at the same population and they realize that some people, the use of AI upskills some people, so it fills certain skills gaps, and then they learn more and they become better at their job. And some people, it's linked to de-skilling. And I tend to agree with you that if you don't know the basics, you will struggle to understand how to use AI well, even how to prompt a large language model. I challenge our students, for example, at the university, if you're not able to think through a problem logically from first principles, AI will really not be of use. And I see pieces of written work generated by AI submitted by students, and you see it quickly because it's not logical, because they haven't mastered the basics of their field. So in that sense, I think your Excel skills are still safe. If we talk about job displacement, I'm one of those people who believe that economic growth is this notion of creative destruction. So it means that when an economy grows, that means certain jobs are not relevant anymore, but enough new jobs are created to make up for the loss of jobs, and enough upskilling and reskilling takes place. So I'm hoping that AI will not merely lead to people losing their jobs, but actually creation of many more new opportunities that weren't previously possible. So that's at least my hope, and it could be possible. We have Tusimunego and Tabiso. Go for it.
Thanks again, Prof. I agree with Tabiso. You need to know at least some information for you to actually use AI. I've been using Perplexity for a while now. And the prompts, the type of questions you ask, the type of answers you want depends on the prompts you ask, and that depends on your knowledge as well. I'll give you two examples. I've been using it a lot for summarizing data. We work with a lot of data with many different topics changing on a daily basis. So it's impossible for you to know everything. So at least you need to know some information. So I use it just to summarize information, so at least I can actually be able to ask questions, especially when you're dealing with specialists who need to do some work for you. There was a topic that was recently started where another provincial government actually had a position paper on it. And we were asked as well, why don't we have same position paper? When you look at that paper, I asked Perplexity to give me this, almost like a summary of that topic. It gave me an exact replica of what was produced by another consultant for the government. So I wanted to ask about that specifically. Using it to summarize, I think it's normal. That's not a problem. But using it to generate data that you're going to sell at a later stage, especially to government, I think that's a problem. Well, the other side is that we think that they used AI, but we're not sure. But what Perplexity generated was an exact replica, was similar. It was very close to exactly the same thing. I don't know what's your view on that, Prof.
Yeah, I mean, it's a good one. The notions of plagiarism become very difficult now. I mean, for me, what the academic journals do, for example, there are some authors who say, okay, we want to add one of the AIs as a co-author. And then most of the journals say, no, we don't allow it. Why? Because only a human can bear responsibility for what they've written. So whatever you present, you need to take responsibility for. And if you say, well, the AI did this, then I mean, you can't. It's just too easy. So I think that principle stays the same. But it's not very easy. I see Benjamin saying government must use Turnitin. Bad news. If you use AI well, Turnitin can't pick it up. So unfortunately not. Maybe a slightly more controversial topic. I think there are certain types of consultancy jobs that will maybe not become irrelevant, but consultancy type firms that need to rethink their business model, I think, in this context. Tabiso, I think, and then Matthew Sebenego. Thanks.
Hi, thank you. Yeah, so I was just thinking as you're talking about jobs, I was thinking of this movie, I don't know, it's Resident Evil or iRobot, where the AI is saying I am inevitable. So the likelihood, I think, is over time, we will have situations where employees are using AI as a tool to obviously help them become more efficient, which is important now, especially in our context where you look at we're under pressure to cut down on cost, but the work is still increasing. So I think that that's a good application, but probably a few years down the line, we'll probably then see AI taking over a lot of other roles. And I think a paper or some policies were being looked at how governments can then pay those people who have who've lost a job as a result, or where we're in an environment where people just don't have to work, and AI does all of these things. So I think that's the interesting part. And then on the issue of data collection, I think that's also where you can integrate AI with this robotic process automation to automate the collection of data, as well as obviously using AI for applications such as your OCR to read documents, learn how to read documents, etc. Thanks.
Yeah, thanks. Yeah, and noted. Absolutely agreed. Yeah. Yeah, thanks. And just before the next speaker, I see NLP is relevant for GTAC. We generate knowledge. We can do so much more efficiently with AI. Absolutely agreed. And it improves your writing. Absolutely. And I do agree that we don't need to tolerate poor writing anymore. But we also, I must say, shouldn't tolerate poor use of AI. I mean, if I get an email from, it has happened, from people where you can say they, in an unreflective manner, use AI, and this long email that basically says nothing. I mean, we should also be strict on that. So if you use AI, you need to use it well. Yes, another, Meneer Matthews, go for it. Thanks.
Just on the follow-up, when you're talking about turning in, is there a tool that can be used to almost like turning in, or find out if the consultants or some of the companies are actually using just AI to generate data and just send it to us? Because I've tried originality AI, but I'm not sure if it's 100% as well. And is there such a thing as 100% as well? Thanks.
Yeah. No, my understanding is no, because I've heard of many cases where the AI, or some cases at least, say the content was generated by AI, and then for a fact it wasn't. And then many more cases, I would say, where the content was generated by AI but we used in a clever way, and the machines don't pick it up. I mean, it does make us ask a lot of questions on what research, what does research mean, for example. I mean, before the era of large language models, much, if not all, most of our research is based on knowledge we don't have in ourselves, but knowledge we find on the internet, we find in peer-reviewed journals. So we don't generate, and I think the same goes for many consultants. The expectation isn't that they generate completely new knowledge in all respects. Apart from, of course, if you need to speak to people and you do questionnaires, that's new knowledge. But in many cases, we rely on other sources for our knowledge. If you use the AI to bring that together in a way, that's logical, where you can take responsibility, where you edit it heavily. I mean, we need to say, is that acceptable by us? Isn't? Does it count as plagiarism? Does it not? When do you acknowledge the AI? So it raises many questions, but we shouldn't overestimate how much new knowledge we created also before the era of AI. Anyway, just maybe that point. So opportunities and risks, things to look out for. So opportunities, as you've said, AI systems used well can dramatically enhance operational efficiency. It can streamline, it can automate certain administrative tasks, especially the administrative tasks that are predictable. I'm no government expert, but my feeling is that, let's say, in a department such as Home Affairs, or if you apply for some licenses in certain other departments, ideally those processes should be predictable, and then they should, to a large extent, be able to be automated through AI. Of course, giving citizens quicker, better access to services can improve service delivery, also to increase the way in which, or improve the way in which citizens provide feedback on service delivery challenges. Higher productivity means higher economic growth. And government resilience also, that's an interesting thing. By using AI to create early warning systems, it can enhance government resilience. Of course, there are downsides. Transparency, fairness, also in the training data, the issue of discrimination built into your training data and then playing out in how the system functions is a huge problem. It needs to be dealt with. Misuse, of course, by bad actors, figuring out who takes accountability. In my view, the ethical approach is that it should always be a human that bears final responsibility. The AI shouldn't make the decision. It's a human that needs to make the final decision and, importantly, bear responsibility. Data protection and privacy, we talked about it. If you have a lot of data, especially sensitive data, you should try to do your utmost to protect that data and ensure privacy of all concerned. There's a procurement piece to this. I don't think government procurement systems are optimized to procure AI systems. That links to other technology systems. I think the old-fashioned way is thinking of IT procurement as you pay a large amount of money to get on-premise systems. Procuring AI certainly, but also other related systems is more analogous to procuring utilities like water and electricity. You have some sort of monthly prediction of how much you'll spend. If people overspend, of course, you need to put in systems to ensure that people don't overspend. If they underspend, of course, you can encourage them to use a bit more. The point is, thinking of procurement needs to be updated a little bit. We talked about a job displacement. Placement is a risk and should be countered actively. That means through active capacity building and upskilling. And in a country like South Africa, we should really do our utmost to make sure that AI use doesn't worsen our high levels of inequality. And that links to an old-fashioned topic, even like just access, broadband access, the cost of data. That's all of it. I mean, when we think of AI, we don't immediately think of just access to internet and the cost of internet, but that's a key topic here. So what can we do to make the most of AI in government? We recently had a roundtable at the Policy Innovation Lab. We were privileged to have the global head of policy from Microsoft, senior representative from Google, from Meta, and also from a South African perspective to talk about making the most of AI in government. And some of these initiatives, incentives, imperatives also emanate from what we discussed there, and we also released a briefing note on that. Firstly, there are a couple of policy imperatives. We need regulation that strike a balance between innovation and risk management. And it's not easy. If you are only focused on risk management, you might kill innovation. However, if you're only focused on innovation, the risks might become unbearable and your citizens suffer as a result. So you need a lot of wisdom, a lot of conversations with relevant stakeholders, and I would say agile policies that can be updated as we learn more to strike that balance between innovation and managing risks. Procurement needs to be modernized. That really is a key point. I know we don't think about procurement when we talk about AI, but I think that's really, really important. Then there are a bunch of societal imperatives. We must ensure that the way we deploy AI promotes inclusivity. And we need to ask the questions, what are the barriers to inclusive uptake of AI? Trust is important. So certainly as a government, if you operate in a society with low levels of AI trust, maybe low levels of trust in government too, I think that's also relevant. You might end up in a bad situation if you're not thoughtful in how you use AI. At scale, we need to develop skills and capacity. This includes people who are not part of the formal education system. I do not think that we can simply say, if you're done with school or if you're done with post-school education, we're not going to do something. I mean, that's really important also for older people. And then last, there are a bunch of innovation imperatives. Increasingly, there's an interest in digital public infrastructure. saying government has a role to play in putting together a government stack of infrastructure that is secure but also accessible, improves the delivery of services through the integration of AI. In the European Union's AI Act, there's also mention of experimental, also policy sandboxes. So in a controlled environment, seeing how a certain technology plays out and then reflecting on what the appropriate policy response should be. And then we can't do any of this without partnerships, government, private sector, civil society, academia. No government, I would say, in the world has the internal knowledge and expertise to devise policies that strike that balance between innovation and risk management. For that, we need partnerships, and it will always, in my view, be a work in progress. So the important thing, I think, of all these imperatives is it needs to be flexible, it needs to be agile, because things are changing so fast. We need to be able to respond and then update how we work with one another or how we craft the policies. That's my couple of words for now. We have about, I think, 10 minutes for a general Q&A. With that, I open the floor. Benjamin, thank you.
Thanks so much, Willem. Okay, one of the issues that we've noticed here at Treasury and GTAC is, especially with note-taking AI apps, wanting to be part of sometimes very sensitive meetings, and with the AI premise of taking information and adding it to its information bank so it can become more clever. It's inadvertently getting access to sometimes very sensitive information of national interest, national whatever, security. Have you guys thought about such things, and what are some of the ideas that you've come up around that?
Thanks. I mean, the first easy thing, Benjamin, is I'll switch off my camera just for the bandwidth, is to kick off all the external note takers from any Teams call. And if you're the organizer, you can do it. I mean, you don't need any note takers from external parties on your Teams call. Secondly, if we talk about the training data, so most of the big companies would say if you have a paid account, they'll have that note where they say your data isn't used to train their AIs. That's if you pay. I would say if you're a government official, you do need to use the paid accounts as a first line of defense, certainly for that sensitive information. Yeah. And then, yeah, please, next question. You can just unmute yourself or comment. You can go for it. Thank you.
Thanks, Prof. It's Charles Moge, Justice Department. I wrote part of it on the chat. I'm doing my doctoral on lean management. And one of the things I'm looking at is the overuse or use of technology, because we are now every one of us is moving to modernization. It's a buzzword. But then the question becomes, in government by its nature, we are not profit-driven, and then the question becomes the issue of human capital and in particular employment. Now, obviously, when we lean or we automate our processes, which I think is good because the AI will work well for one of our processes in maintenance. The only challenge is the balance, because most of the time we don't do that in government. We introduce this online and technologies, we forget the human who was there. And then later we don't know what to do with that person. And I think that's one of the things that will get resistance in particular, because you don't want to risk to start reducing employment in government because of technology. So how do you think we're going to navigate that problem, unlike in the private sector?
Yeah, it's not easy, and I think it requires sustained effort. We shouldn't just forget about it, because in all organizations you do something and then you don't have a champion that keeps an eye on it. In terms of employment, some people say that the best case scenario is that the AIs are deployed. Oh, yeah, great. That the AIs are deployed on the on the tasks that people typically don't want to do, or the tasks that can be automated, or the tasks that don't really require human intelligence or human
Sorry, Willem,
creativity.
can we just ask that people mute whoever's unmuted?
Thanks, Elaine.
Sorry.
Yes.
Sorry.
I thought I was just trying to push through, but this is helping. Anyway, so the point is using the AIs on the stuff that humans don't find stimulating, where you don't need human intelligence or creativity. That's the best case scenario. And then with the time that's now available to that human being, upskilling them, using them in other places. I mean, in government, there's always another place, or within your department, where those human skills can be used. That's the dream. But that will require really constant attention. Yes. Tabiso.
So I'm just curious, is AI going to achieve consciousness, and what happens then?
A loaded question. So the question under that is, what does it mean to be conscious as a human being? If you start diving into some of the psychology, at least, and I went into that a little bit to answer that question for myself also, is that it's not immediately clear what human consciousness means. And then there's a second, in my view, related point is, I don't think the biggest problem of AI is if they're conscious. I think there are more dangerous, I mean, there are other bigger problems rather than consciousness. But I don't think it will be that. My reading of the literature at present is that it might not be that easy to determine when AIs are conscious, and that's partly because we're not that clear actually in what human consciousness means, what the main characteristics are. But I could be wrong. That's not my total field of expertise. Thanks. Then Sibunego.
Sorry, Willem. Sorry for jumping in, but would you mind maybe just to take this, like 2 questions on the chat just for now? I think they've been queuing.
Oh, yes.
As well. Okay. Sorry if you don't mind. Maybe start there with Dr. Bahrain's question on
DeepSeek.
DeepSeek, and then the one below from Kanya as well, before we go to the other hands. Thank you. Sorry, Willem.
No, gladly. So on DeepSeek, I don't have a specific view on safety, security, as I don't have a specific view on the other models. What I can say is that you currently have 2 types of broadly seen large language models. Those that you run through the servers of other companies, which may or may not be completely safe. I mean, maybe. And then you also have large language models that you actually download to your own machines, and you train them and you keep them confined with within your own environment. I think Meta, for example, the company, their model you can just download. My view would be, and I stand under correction, is that if you're really serious about using AI systems for very sensitive information, I would rather take a sophisticated model and run it from within your own controlled environment. But again, it's not my total field of expertise, but that would be my approach. DeepSeek is interesting, maybe just for the others. The big controversy related to DeepSeek is let's say the mostly American companies said they need a lot of hardware, expensive hardware. They talk about GPUs, graphical processing units, to train their AIs. And then this Chinese company came and they showed that they can do the same or reach the same sort of outcomes with much less hardware and much cheaper, basically. And that was a very dramatic happening in the AI community. Kanya said, I'm just going to read it here. Is there any committee at national level that evaluates digitalization strategies for government, seeing that there's so much fruitless expenditure, etc.? I don't know, Rick, on the expenditure side whether there's a committee managing that. I know in terms of the digitalization or digital transformation journey, also as it relates to the use of digital public infrastructure. I think there are units at the center of government driving that. I think recently served at cabinet. I think at the most recent cabinet meeting, there was a strategy roadmap, digital transformation roadmap that was approved, but I'm not sure on the expenditure side who's tracking that. And then just request for presentations. Yes, I'll send the presentation to Nobuntu. We have 1 minute. Sibunego Matthews, go for it.
I was just curious about on the imperatives and the recommendations. You mentioned experimental sandboxes. Is there any examples of it? Is there any talks about that in South Africa or anywhere else? Thanks.
So I think in the AI strategy process driven by a bunch of actors, I think from NACI to CSR and others, I think there is talk about those sandboxes. There could be active sandboxes, but I'm not aware of them, which again doesn't mean that they're not active. Just within my sort of field of experience, I don't know of them. But yeah, that's as I've said, in the European Union's AI Act, they really do mention that as a good practice. With that, I'm handing the virtual mic back to you, Nobuntu, and thank everybody for the wonderful opportunity on this Friday afternoon to share some thoughts with you. Maybe to conclude, it's difficult to say that one is an expert on AI because it is such an expansive topic. I know a bit from our direct experience. There are many people who know much more, but I do hope that there were some elements in the presentation today that could be of use to you also in your work. Thank you very much.
Thank you so much, Professor Fourie, for such an insightful presentation. It was quite great to learn that actually the AI actually mimics our human intelligence. What you feed it is what you're going to get out, the output. Thank you so much for that. And thank you, colleagues, for joining us this afternoon. Please be reminded to check our post-webinars on our YouTube as well as on our website on the Knowledge Hub. We will have this presentation on those platforms as well. Don't forget to rate us. How was the presentation and how was the session? Thank you and have a great weekend further. And thank you again, Professor Fourie.
Thank you, Matt. Thank you very much, everybody. Have a great afternoon. Bye-bye.
Goodbye.
Thank you.
Bye.
Thank you. But goodbye.
Thank you. Bye.
Bye.
Thank you. Bye.
Thank you. Bye-bye.
Bye.
Bye.
Thank you. Bye.